Okay, here we go. Let's continue on number 21 to finish this review. Number 21 says, describe how to transform the graph of f of x equals x squared to obtain the graph of the related function g of x equals negative 3 f of x plus 1 minus 5. Okay, in your review, I believe there is a typo. I think it says this, x squared plus 1 and then minus 5. That is incorrect. There should be no x squared in there. Okay, we either write just f of x plus 1, or we write negative 3 times x, the quantity x plus 1 squared minus 5 to show that the entire thing is squared. Okay, but the way that it's written in your review, which I believe is this one right here, that's incorrect. Okay, let me just erase this. And let's answer the question. It says, describe how to transform the graph to obtain this graph. Okay, so basically I'm just looking at g of x to see what changes happened from f of x. The first thing I see is x plus 1 right there. Okay, actually what I'm going to do is find b, h, a, and k, right? Because we always do that, so I want to make sure I know how to do these. B, h, a, and k. Boy, hungry, ate kitty. B is always the number that is next to x, right? There's 1 over b and then x plus something, x minus h. Now in this case there's nothing there right next to the x, right? So b is 1. Now h is inside of the parentheses with x, so it's always x minus h. So in this case, since it says x plus 1, that means h is negative 1. A is the number in front. It's always up here in front of the function, right? A times f of something. So a is the coefficient up there in front, which means that in this case a is negative 3. And k is the number that is being added at the end, right? That single constant at the end. So in this case, k is negative 5. Now using those values, I can now tell what transformations happen to this graph. Okay, so starting with B, B represents a horizontal stretch or compression or a reflection. Since B is just 1, B does nothing in this case, right? We don't even have to mention it. You could say it's a stretch by a factor of 1, but that actually doesn't mean anything. It doesn't change anything. Let's go to H. H is a translation by a factor of, not by a factor of, translation in which direction is what we need to say. Translation to the, since h is negative, that means to the left 1 unit. A is negative 3. That's a couple of different things in there. Okay, first the 3 means a stretch. The 3 represents a stretch by a factor of 3. Oh, and before we forget, we need to specify what kind of stretch. So let me just fix this real quick. What kind of stretch? A vertical stretch, right? Because otherwise we're going to think it might be horizontal. Vertical stretch by a factor of 3. Also, since A is negative, it also represents a reflection. And when you write reflection, you have to specify, is it across the x-axis or across the y-axis? Right? We have to specify what type of reflection this is. So in this case, since it's a vertical reflection, right? A is always a vertical. It's either a vertical stretch or compression or a vertical reflection. Since it's a vertical reflection, that means you're going from top to bottom or from bottom to top. You're jumping over the x-axis. And finally, k is equal to negative 5. That is simply a translation, right? K always represents a vertical translation. Translation down 5 units. And that's it. Okay, those are the 4 transformations that happen in this function. Okay, number 22, it says find the inverse function, f inverse, for the function f of x equals negative 1 half x minus 3. Okay, so let's go through the steps of finding the inverse function. First thing I'm going to do is replace f of x with y. So what I write is y equals negative 1 half x minus 3. Then what I do is the next step is to flip the x with the y. So I'm going to reverse x with y. This is x now. Then what I'm going to do is solve for y, right? Isolate the y. So what I'm going to do first is add 3 to both sides. Some of you guys might choose to multiply by the reciprocal to get rid of the fraction. Either way is correct. Add 3 on both sides. That was incorrect. I was adding 3 to the same side. So that 3 cancels, and so it leaves me with negative 1 half y on the right side. On the left side, it's x plus 3. And finally, I'm going to get rid of the 1 half of the negative 1 half, by multiplying by the reciprocal, which is negative 2 over 1, which is going to cancel, and the negative will also cancel, leaving me with just y on the right side. On the left side, I need to multiply by negative 2, right? Just negative 2 over 1, so it's going to give me negative 2x minus 6. Okay, so step 1, I've changed f of x to y. Step 2, I reversed the x and the y with each other. So instead of y, it is now x, and instead of x, it is now y. Then step 3, I solved for y. I isolated the y. There it is. And finally, I replaced the y with f inverse. Okay, so I'm going to replace that with f inverse, and I'm done. F inverse is equal to negative 2x minus 6. And that's my inverse. Now I'm going to check this to make sure that it's correct. Okay, so if you remember how to check these, you're going to do a composition, right? You're going to plug f into f inverse, or if inverse into f, like this. We're going to plug in f inverse into f, okay? Which means that I'm going to write f of x, which is negative 1 half x minus 3. But right there, instead of x, I am going to plug in the entire inverse function that I just found, negative 2x minus 6. And that will allow me to check if my inverse is correct. If I get x, simply x, that means that my inverse is correct. So here we go. Distribute the negative 1 half. Negative times negative is positive. The 1 half and the 2 are going to cancel, leaving you with just x on that very first one. Next, I'm going to multiply negative 1 half times negative 6. Negative times negative will be positive. 6 over 2, which is 3. And then at the end, there's a minus 3 there, which will cancel each other out, leaving me with just x. So the composition of f with its inverse is x, which means that my function that I got before is correct. This is correct. Okay, 23 and 24, it says, describe how the graph of g of x is related to the graph of f of x, which is x cubed, right? So it's basically another transformations problem, except I'm talking about cubic functions now instead of quadratics, but basically the idea is the same. So if I look up g of x, and I look for b, h, a, and k, that will allow me to determine what's happening in this function. Right? B is 1, so I don't see anything there in a fraction. H is not 2, it's negative 2. A is 1, and K is 0 because there's no constant there being added to it. Okay? So the only one that really matters here is the H, which is negative 2, because B and A, if they're 1, they don't do anything. K, since it's 0, it doesn't do anything. So what happened here, it's basically a translation to the left. Why left? Because h is negative 2. 2 units. And that's it. For 24, I compare that to f of x equals x cubed. Once again, I look for b, h, a, and k. Boy hungry, ate kitty. B is always going to be inside of parentheses. It's right next to x, but inside of parentheses, like this, okay? So if there's a B, it is right here. 1 over b x, and then the cube is outside like that. So don't get confused. Don't think b is 2 here or negative 2. It is not inside of the parentheses with the cube outside. So b, once again, is 1. H would also be inside of parentheses here, like that. Since there's nothing there, h is 0. A, that's what that negative 1/2 is. That is A. A is here, in front of everything, of the parentheses. And K is once again 0. So here in this one, the only one that matters is A. Right? The other ones did not make a difference at all. They'll make a change. So what does that A do? Since it's 1/2, that's a compression. Not a stretch. It's 1/2. It's less than 1. That means a compression by a factor of 1/2. Vertical compression, we must say. It's not a horizontal compression. Vertical compression by a factor of 1/2. And then that negative for A also causes a reflection. Reflection. Across which axis? We'll think about it. It's a vertical reflection, right? From top to bottom or from bottom to top, which is a reflection across x-axis, not y-axis. Okay, so let's keep going. It says for 25, use a graphing calculator to graph the function. We're going to scratch that because we do not use a graphing calculator. We can graph these without a graphing calculator using the methods that I showed you. Okay. Then use the graph to determine the number of turning points, the number and type of global or local of any maximum or minimum values, right? So we've been practicing this for this past week. So let's start by graphing the function. Okay. To graph the function, what I need is to know the end behavior and the zeros. Let's start with zeros. To find the zeros, all I got to do is split up this function, set it equal to 0. Split up its factors and set each one equal to 0. So for example, that first one is this one right here. That's a factor. So x equals 0. The next one is x plus 2. So you're going to say x plus 2 equals 0. Which when you solve will give you x equals negative 2, right? Because you subtract 2. And the last one is this one, x plus 1, which will give you x plus 1 equals 0, which means that x equals negative 1. So my zeros are 0, 2, and negative 1. Next, what I'm going to determine is the end behavior. So my end behavior will be determined by the first term of each factor. X, x, and x, multiply them all by each other so you get x cubed. So you look at that x cubed and you figure out, okay, well, from that x cubed, what is a and what is n? And a lot of people still are confusing which one is a and which one is n. A is always in front of the x and n is the exponent. Okay? So in this case, a is 1 and n is 3. Now using my end behavior table, which I'm going to do right here, a positive, a negative, right? N even and n odd. I can figure out the end behavior, right? N even and a positive means up and up, which means that a negative and n even means down and down. Remember that? A positive with n odd, look at your notes and or else memorize this already. It should be down and up. And a negative and n odd should be up and down. So using that and these two numbers right here, a is positive and n is odd, which means that my end behavior is down and up. Okay? So that pretty much gives me enough information. The only thing left to do is to figure out if it's going to be crossing at each of those zeros, right? If it's going to be crossing or just being tangent or just touching those points, okay? So my end behavior is, once again, I'm going to write it down here, down and up. Okay, so by looking at those zeros, remember you determine the multiplicity, okay, how many times those zeros are actual solutions of this graph. So for x equals 0, the multiplicity is 1, because there's only one of those. For x equals -2, the multiplicity is also 1. And for x equals -1, the multiplicity is also 1. So for all of them, the multiplicity is 1. So remember, since that is odd, you remember this, ETOC, even touches, odd crosses. So each one of these, it will cross at those zeros. For each one of these 3 points, 3 zeros, it will cross at those points. So we're ready to graph. Looks like this. Here's my x-axis. Here's my y-axis. There's my x-axis right there. The y-axis we really do not care much about, right? Because we don't know how high up it's going to go. So for the zeros, we have, put them in red here, 0, 2, and -1. Those are my 3 zeros. So my line is going to cross through each one of those 3 points. It crosses, right? That's what we learned, that everything crosses here. Next, the end behavior is down and up, which means that on the left side it's down, and on the right side it's up, like that. And then using the fact that it's going to cross in every single one of these points, because the multiplicity is 1, which is odd, I can draw my line like this. It's going to cross through there, cross back down through there, and cross back up through there. There's my graph. So the question says, determine the number of turning points, the number and type of any maximum or minimum values. Okay, so let's start with turning points. How many turning points do we see? Well, every time that it changes direction is a turning point. So 1, 2. That's it. 2 turning points. Two turning points. Number and type of maximum or minimum values. Okay, so I see 1 local maximum right here and 1 local minimum right here. You see that? 1 local maximum and 1 local minimum. 1 local max and 1 local min. What about global maximums or minimums? Maxima or minima? There aren't any, right? This graph will keep going forever in the positive direction and in the negative direction. So it will not have any global max or global min. Okay? So we're going to put no global max / min. There aren't any. So that's it. 2 turning points, 1 local max, 1 local min, no global max or min. Okay, number 26 says, write the inverse of the function as a set of ordered pairs. Then plot the ordered pairs for the inverse on the grid. Okay, we didn't really get to do many problems like this, although it's a really easy problem. Okay, because we're looking for the inverse, and the inverse is very easy to find if all they give you is a set of points. So what I'm going to do first is write these set of points in a table. Not the inverse points, but just these points that they gave me. Okay, each one of these points has an x and a y coordinate, so I'm just going to put them all in a table. Start with this one right here. That would be -4, +3, right? Then this one right here is -3, +2. This one is -1, +3. This one is 1, negative 2. This one is 2, negative 4. And the last one is 4, negative 3. Pretty simple. Just get those points from the graph. Now I'm looking for the inverse. Remember, the inverse just reverses the value of x with y. So my inverse will look like this. 3, negative 4. Where do I get the 3, negative 4 from? From here, negative 4, 3. Right? The next one is 2, negative 3, because I'm reversing the values. 2, negative 3, 3, negative 1, negative 2, 1, negative 4, 2, and finally negative 3, 4. That's it. That's the inverse. Second part of the problem says plot the order pairs for the inverse on the grid. So basically just take these points that we just found, all of these, and plot them on the grid over here. So here we go. 3, negative 4 is right here. 2, negative 3 right there. 3, negative 1. Negative 2, 1. Negative 4, 2. And negative 3, 4. And that's it. Those are your inverse. Those are the points plotted of the inverse. Okay, number 27, choose true or false for each statement about this function, f of x equals x cubed. Let's go one by one and figure out if they're true or false. Okay, part A, the function is even. Okay, how can we tell that the function is even? You can either tell by graphing it, see if it's symmetrical, okay, or what we can do is plug in negative x in for x. Okay, remember, if you're checking for a function to be even, what you're going to do is do with black in this case. What you're going to do is you're going to replace the x with negative x and see what you get. So if I do that in this function, which is x cubed, and I put negative x there, f of negative x equals negative x cubed. What's going to happen when I cube this negative x? Negative x times negative x times negative x will give me negative, because negative times negative times negative will still end up being negative x cubed. So how do I know if it's even or odd? If I get back the same thing, if I replace x with negative x and I get back the exact same function, then it's called even. If I get back the exact opposite, which means that if it used to be positive and now it's negative, then we call it odd. So in this case, I did not get back the exact same thing, which means that this function is not even. So first part is false. Part B, the function is negative where x is less than 0. The function is negative where x is less than 0. So what you do to check this one is pick a number less than 0. For example, negative 1, or negative 2, or negative 3. Plug them in to see if you do get a negative, like part B says. The function is negative. Okay? And when you plug those in, you'll see that no matter what you plug in, if it's negative, negative 1, negative 2, negative 3, negative 4, negative whatever you want, when you cube it, you are always going to get a negative. So that part is true. You'll get a negative. Okay, part C. Notice the way that this is written. It says, as the function f of x approaches infinity. That's what this means. As f of x approaches infinity. As the function approaches infinity, then x approaches negative infinity. What does that mean? Okay, let's replace this f of x with y. It'll make it easier to understand. Replace the f of x with y. So what it's saying here is that as y gets bigger and bigger in the positive direction, then x gets bigger and bigger in the negative direction. Is this true? Okay, let's check. as x keeps getting bigger and bigger in the negative direction, -4, -5, -6, let's say I keep going, -100, -1,000,000, will y start getting positive? Will it start going bigger and bigger in the positive direction? And the answer is no, right? What this is saying is that as y gets more positive, x gets more negative. That is not true. As y gets more negative, x gets more negative, okay? The opposite is true. If y gets more positive, then x gets more positive. So this one is false. And finally, the function is symmetric about the origin, okay? So remember what this graph looks like. Something like that. It is not symmetric about the x-axis. It is not symmetric about the y-axis. But we do call this symmetric about the origin, which is right there, because we can basically take this function and rotate it 180 degrees and it will land exactly on this one. So this one is true. Okay, number 28, choose true or false for each statement about this function. F of x equals -x to the 12th power. So we're going to follow the same steps as before, okay? First thing is check if the function is even. So remember, for that, you're going to replace x with -x and see what you get. So make sure you're careful when you're writing this one. You're writing negative because it's already there inside in the function, and then you're replacing the x with -x to the 12th power. So let's think about what this represents, right? We have -x to the 12th power. What's going to happen when you multiply -x times -x times -x times -x and so on 12 different times, okay? What's going to be negative times negative times negative times negative times negative times negative and so on. Since it's an even number of times that you're multiplying it, right? Negative times negative and then times negative and so on. This whole thing right here, not including this negative outside, but this right here will end up being positive x to the 12th power. So I will have this. There's this negative, which is basically this one right here. And then -x to the 12th power will become x to the 12th power. And again, how do we check if it's even or odd? We check by looking at when we replace x with -x, did we get back the exact same thing or did we get back the opposite of the original? In this case, this is what we started with, this is what we ended with. Okay, so since we got back the exact same function, this function is called even. True. Okay, the domain of the function is -infinity to +infinity. Okay, -infinity to +infinity. That means that x could be anything on the negative side, y could be anything on the positive side. Okay, it goes from all the way from -infinity to +infinity. In this case, that is true. Okay, because the end behavior of this function, if you think about it, n is 12 and a is -1. So that's even and negative, which means that the end behavior is down and down. So if I look at this graph, it's going to be down and down, okay? And it's going to be symmetric about the y-axis. So this graph will keep going forever towards the left direction and forever towards the right direction, right? So I don't know what it looks like here. All I know is that symmetric because it's even, and it goes in all directions on the left and on the right. Okay, so the domain of the function is -infinity to +infinity. True. The range of the function is -infinity to +infinity. This one is false because the graph is down and down as its end behavior. That means that it does go all the way to -infinity, right? It's going to keep going down forever, but it does not keep going up forever. There's going to be some point where it has a maximum. Okay, so this one is false. And finally, as x approaches infinity, f of x approaches infinity. If you want to think about this easier, replace f of x with y, and then picture that. As x gets bigger and bigger, does y also keep getting bigger and bigger in the positive direction? Think about it as you look at this graph. As x keeps going to the right, keeps getting bigger and bigger, does the y value keep getting bigger and bigger in the positive direction? No. As x keeps going to the right, y keeps going down, not up. Okay, so this one is actually false. Okay, so this is the last one of the review, and this one might be the toughest, maybe not the toughest one, but the one that people will probably struggle with because it's kind of new. Okay, so it says write a quartic function in intercept form for the given graph whose x-intercepts are integers. Assume that the constant factor a is either 1 or -1. Okay, so we're not going to worry about this last section right here. What I'm going to worry first is writing the quartic function. Now quartic means that it's to the 4th power, right? It has x to the 4th power. That's quartic. So what I'm going to do first is find the zeros of this graph. Okay, and the zeros are very easy to find by just looking at the graph and seeing where it crosses the x-axis, because the zeros and the x-intercepts are the same thing. So right away I can see one of the zeros is -1, another one is 2, and the other one is 3. So -1, 2, and 3. Okay, still following me along? So I got those 3 from looking at the graph and seeing where it crosses or touches the x-axis, right? Now what I'm going to do is work my way backwards, okay? What I mean by work my way backwards is for each of those 3 zeros, what are the factors that gave me those zeros? So for example, if I say my factors are x plus 2 and x minus 7, what are the zeros? Well, then you would say x plus 2 equals 0, which means that x equals -2. X minus 7 equals 0, which means that x equals 7, right? So if I work backwards for the zeros that I already have here, -1, 2, and 3, what are the factors that gave me each one of those? Okay, so for -1, what gives me -1 as a factor? X plus 1. Okay, how do I get that? If I solve x plus 1 equal to 0, then I'm going to get x equals -1, right? So you're basically working your way backwards. What gives you 2? Which factor gives you 2? X minus 2. And which factor gives you 3? What do I have to have here so I could get 3 as one of my zeros? X minus 3. Okay. Next, what I'm going to determine is how many times does each one of these zeros happen to be a 0. So for example, here at -1, does the graph cross or just touch? You can see that it doesn't cross, right? It touches, which means that the multiplicity of this one is even. Okay. At right here, does it touch or cross? It crosses, which means that the multiplicity is odd. Here at 3, does it touch or cross? It crosses, so the multiplicity is odd. So x minus 3 will have an odd multiplicity, meaning that it happens only once. This one happens only once because it only crosses. But for -1, the multiplicity is even. It has to happen more than once. It can't be 1. So it must be 2. So -1 actually happens twice. Okay? Which means that here all I need to put is x plus 1 squared. Now does that give me a quartic function? And it does, right? X times x squared is x to the 4th, so it gives me a quartic function. Okay? And finally, all I have to do is just write y is equal to this function. Now it says assume that the constant factor in a is either 1 or -1, right? So a is not any other number. I could make it any number I want and it would still work. Now the last thing I need to check is, does this graph have an end behavior or of up and up or down and down, or what is the end behavior? Okay, you can see that it's up and up. So is a positive or negative if the end behavior is up and up? Positive, right? Which means that a has to be 1. It's either 1 or -1. Those are the only options. Okay, if the end behavior was down and down or something with down, then it would probably be negative. There it is. That's your final function for this situation.